Hello guys, I'm back. Okay, so many students ask me how to do this problem because this problem was probably in the homework. It was an FRQ problem, but they simply didn't got any idea about it. So let's look at the question. At time t greater or equal to 0, the volume of a sphere is increasing at a rate of proportional to the reciprocal of the radius. Look at that, that is important, the reciprocal of the radius. At t equal to 0, the radius of the sphere is 1, and at t equals to 15, the radius is 2. So, for the A question, find the radius of the sphere as a function of t. As you think of it, what can you come up with? It is a sphere, right? And it looked like a finding the derivative question. So, let's find the derivative of the formula. Okay, let's first write out the formula. So what is the formula of the sphere? That's V equal to 4 over 3 pi r cubed, right? That's really easy. You must know it. And then, how can you do it further? Find the derivative on both sides, right? Using dv over dt and dr over dt, right? So that's dv over dt equal to 4 pi r squared, because I already found the derivative of that, times dr over dt, right? This is still easy. Then we know that here, the rate of the volume, here, volume, is proportional to the reciprocal of the radius. In your Algebra 2 class, do you still remember what does proportional mean? Does that mean it is somehow a constant times something? That means it is proportional to? Okay then, so then let's set dv over dt equal to k, a random constant times something. What is it proportional to? The reciprocal of the radius. Then that's 1 over r. So that equal to k over r, right? So can we then plug this whole thing in here? Can we? Of course we can. Let's do it. K over r equals to 4 pi r squared dr over dt. We just plug it in. And then move r to this side. We will get k equal to 4 pi r cubed dr over dt. Look at it. dt is still on the bottom, right? Do you like it? I don't like it. I will move dt onto the other side so that I can get rid of dt and get the variable t into the function. Let's move. Then that's k dt equal to 4 pi r cubed dr. Right? What should you do next? I got d on both sides. What should I do? I should integrate on both sides, right? So let's integrate. What's the left? The left is changed to kt, right? Because k is a constant. It is not a variable. It is a constant. Leave it alone. It is a coefficient now. So what's on the right? That's pi to the fourth, right? Pi r to the fourth, right? It's too easy, the power rule, right? So I already integrated on both sides. What do I need now? I need a plus c, right? This is important because you need to come up with that when you were really in the AP test. Okay then, what should I do? I know that this function is passing through the point 0, 1, and 15, 2, right? Can I plug these into a whole long system of equations? Of course I can, so let's plug it in. Then I will get c equals to negative pi, right? And what should I do on the other side? For the second point, plug it in. Let's write it out. It can be a little bit hard. Then that will be 16 pi. That's 2 to the fourth. Minus pi, right? Equals to 15 k, right? Because k is 15, and c is negative pi, and r is 2, and 2 to the fourth is 16. That's apparent. So what is k? k is pi. Above all, for all of these, what can we get further back? When we plug k and t back in, we can get pi t equals to pi r to the fourth minus pi. What do you discover in this equation? There's a t, but there's a disgusting pi in it. Do you like it? I don't like it, so let's leave them alone. This changes to 1. So that will make it t equals to r to the fourth minus 1. So r to the fourth equal to t plus 1. You can stop there. Of course, if you prefer to simplify, then you can also put it r equals to t plus 1 to the 1 over 4. It's all good. So for number B, that will make life a lot easier. So it's at what time t where the volume of the sphere will be 27 times its volume at t equal to 0. Whatever the volume, the radius or the volume is at 0, r is expanded 3 times, right? Is this true? Is this apparent? Probably it's a little bit hard. Let's set it. Let's set V0 be the volume when t equal to 0. And let's set R0 be the radius at t equal to 0. Then I got it's 27 times its volume, right? So what should I do? That's 27 V0 equal to 4 over 3 pi. The whole thing is a constant, so leave it alone. What can I do? I can time 27 to the R0 cubed, right? So 27 is how many cubed? That is 3 cubed, right? This is apparent. So then we know our final, I will write RF equal to 3R0, right? Then when I really plug back in, R0 here is in the question. It is 1. Then RF equal to 3. Right? R equal to R final equal to 3. Then what should I do? I should plug this back into the equation I got in question A. This is the reason why some of them got stuck, because they didn't even solve A and they saw B really easy, so they tried and they failed. So then that's 3 to the fourth equal to 1 plus t, right? Is that apparent? 81 equals to 1 plus t. So what is t? T is 80. So now you got the answer for both questions. For the first question, you can leave it here. You can also leave it here. You can leave it here. For the second question, when plugged back in, the answer is t equal to 80. Thank you for your listening.